minutes, so 8:05 we are going to start, right?
Okay, sir.
Okay. I thought like it is going to go like more, with the energy. So everybody is still like, I agree with Vikas sir, like everybody is sleeping, isn't it, guys? Okay. We are not going to wait anymore. Still, I can see 53. So we are going to start. So what experiment we are going to do? Anybody has the idea, or we are in the last year, 2021?
Sir, conductometric
titration.
I see Nakshatra and Varun is saying conductometry, but I thought like maybe we are doing the chloride estimation, isn't it?
No, sir.
We did it.
No, sir.
Okay, so let me just try to share the slide. Okay, can you see?
Yes, sir.
Yes.
Right. So as you know, today we are going to do this so-called conductometric titration. I will be more interacting actually in terms of understanding this thing, so that the most of the theory part you are, very used to. And the idea is like once you are, clear with that one, the experiment goes quite easier, right? So here what we are going to do the experiment today, we are going to do the conductometric titration for the solids, right?
No, not for solids, sir.
Okay, so I only study like there is some conductivity, and obviously like when the heat or energy transfer, that's how I understand. But if you're not saying like it is for the solid, then for what we are going to do it today?
So hydrochloric acid solution.
Okay, anybody else want to try? Is it like a solid, liquid, or gas? What kind of phases we are going to see here today? I think you already answered, but let me see.
Liquid state.
Liquid.
Okay.
So liquid state?
Yeah.
Liquid state.
So here we already studied when you might have read in the physics or chemistry part. You might have read about like how the conductivity is working. One of the best example people always give that, if there is a rod, like the iron rod, and you are putting a heat on one side, after some time the heat is going to come to the other side, and you know the concept behind it, right?
Yes, sir.
Yes, sir.
Right. So what is happening, it is transferring the energy from one particle to other one, and that is why the heat is coming to the other side, right? Here what is happening actually, like and perhaps do you have any idea like what kind of this titration is, the conductometric titration? What is the another kind of titration we are going to call it?
The acid base.
That's correct. Okay, so it looks like you are not sleeping and you are very attentive, and then you are trying to bring it that way. So obviously like there is some chemical reaction is happening. Obviously, since it is the liquid, you are trying to talk about the electrolyte, and once that reaction is happening, obviously with that charge transfer, then you are going to get the the energy, right? Here, if you have to talk about the history, about the conductive measurements, you can see there was a guy called Andreas uh, Baumgartner who has observed the salt and mineral who can conduct the electricity. I don't know whether you are aware that if you are warming the water and then you put some salt, obviously if there is a I think this is little bit on the winter side, so you can, because we are not facing a lot of winter, but obviously most of the places where you go to the little bit middle part of India and to go towards Delhi, that side actually like too much, winter is coming. So people try to use, I don't know, everybody takes the hot water bath or the cold water bath because that is very, very important to see. And they used to put some rod there, right? Just to warm the water. How many of you have done that? Or do you
Sir,
have any idea?
yes, sir. I've seen that. In the hostels, we use that usually.
Yeah, that's very good actually. So what you try to do actually, like when it is heating, obviously you can put your fingers there just to check whether the water is hot or not. How you check it?
Sir, no, sir. We turn off the switch, we take that rod out, then we check the water is hot or not.
Yeah, the question is why?
Sir, because the rod is carrying electricity throughout it, and it is making the water warm through passing electricity. And if we touch that water, it will shock us.
Yeah, but why it is going to shock us? Because in the water there is some minerals which is going to help in the conductivity process, isn't it?
Yes, sir.
So,
Yes,
so you are going to get the shock because of the energy is going to come to you, right? And that is the certain instant energy it is coming. That's why you are getting the shock, right?
Yes, sir.
Okay, so you got that one. So that is why if you see this Andreas Begum Carter, what he has done actually, he has absorbed the salt and the mineral water, the conduct electricity. So that is the concept I was trying to bring it to you actually, so that you are quite aware with that. And we are doing every day, but we do not see what is happening, in terms of the chemistry point of view actually, right? And obviously if there is like sea ocean, okay, because we are covered most of the India, actually the Indian part is mostly covered by the Arabic Sea as well as the Indian Ocean, isn't it? Right?
yes, sir.
Okay, so in there, if you are trying to collect maximum part of, like let's say a bucket of water, I don't know how many of you have done there. Okay, and if you are putting little bit like electricity there, do you think like that is going to conduct some, the energy or not?
Sir, it will conduct, sir.
It will conduct because there is a highly reach of
Salt
Minerals,
in the
salt,
water.
salt and minerals.
the salt actually. Salt is a
Salt.
lot actually. Okay, and if you have seen the history, you might recall there was a history incident in some year, and it is popularly known as Dandi March, done by Mahatma Gandhi.
Yes,
You
sir.
know that? So what he has done there?
So boiled seawater to manufacture salt.
There you go. So now you know actually, so nobody is going to be confused with that, right? But obviously, like that salt, whether it is going to carrying some other kind of elements where you are looking for the iodine or something, that is the way you try to do with the help of other kind of smaller industry when they try to mix it. And now you eat what is called Tata salt or other kind of things what you are getting from the shopping malls, right? So obviously you know that like there is in reach of the salt, and peoples who are doing good kind of research actually, one of the process, I'm just giving you a little bit good idea in terms of uh, growing your interest towards the chemistry and some solution you can think in the near future, because you guys are the future like a good engineers, right? So you can see actually like if we try to remove the salt from the sea, what is going to be there? Is it not? It is only the water is going to be there, right?
Yes,
Yes or
sir.
no?
Yes, sir.
Obviously. So if the water is there and then you are further making the chemical reaction in terms of splitting, what you are going to get? The hydrogen as well as oxygen, right?
Yes, sir.
Yes, sir.
So if you can try to think about the processes where you are going to look at your, like you can try to take out the salt out, that is called desalination process. I don't know whether you are aware with that, right?
Yes, sir. Aware of that part.
Right, because I came basically from South Africa, and if you try to read some news around 4 years along the time, in Cape Town there was a zero water, right? Have you heard that news?
Yes, sir. The
So
Yes,
drinking
sir.
water was quite limited to people around in Cape Town,
yeah, it
and
was
was
not
one of the first
only
countries, was one of the
yes.
first city in the world to experience this.
Yes, and that is you perhaps you are you may be aware that that is one of the best country like best city in South Africa. Everybody want to go and see the city. Most of the tourist people go there because there is a small Robben Island where Nelson Mandela was kept in jail, and also there is a Table Mountain. And table means like how you see in your house a kind of table, right? So that is a kind of mountain is there, so that is a Table Mountain. Everybody go. I try to even hike. It's obviously like quite a tough job, right? So if you are going there you can see, but the whole idea is like that is the only kind of province. Like here we call it a state in India. In South Africa we call it province, so that is called Western Cape province, and ruled by the white people. And they try to say that they are not going to experience this kind of water problem. So when the peoples were trying to suggest, because Cape Town, if you see the area, there is two kind of ocean is meeting. I don't know whether you have the geographical information, but if you see there is the Indian Ocean as well as the Atlantic Ocean, right? Okay, so they like they have enriched up a lot the sea water, and they could have thought about the desalination process, what we are talking about today as well, right? Obviously, like we are not talking about in today's experiment, but I'm just giving you a little bit flavor so that you can think about that desalination process. And when you take out the saline, which is called the salt out from the water, obviously like you have the hydrogen and the oxygen out of it, and there is a now newer technologies available especially for the new cars based on the hydrogen fuels. I don't know whether you know about that car which is getting very popular nowadays.
Yes, sir.
Anybody? Yeah, do you know the
Yes,
car
sir. It is
name?
a fairly new concept as hydrogen cars, but it is still
Yes,
growing.
and the company is Tesla, right? And the owner is Elon Musk. You know that, right?
Yes, sir.
Elon
True.
Musk is also a South African guy who shifted to Canada because his mother is there, right? And then obviously, like he has started this business by his own, and obviously now you can see you. So the EG concept, what is coming there, like how I was trying to get you the story, like the solution is in front of you. Sometimes if you think a little bit on wiser level or the engineering kind of model, obviously like you can think some solution. So you have a lot of seawater, and obviously like with the seawater you can remove the salt, that is called desalination process, and obviously you can have the water many ways. Like Africa is mainly like it's a bigger issues for the water. They don't have clean water. Obviously they don't want the clean water, the politically or the way you can try to see. So the whole idea is like how you can try to provide some solution, right? And once you have taken out the clean water, and then you can try to see like what kind of other energy kind of solution you can bring it. So you are engineer, so you can think bigger direction. So obviously what we come back to here actually, like he has the salt, the Andreas Water, and then that's how he tried to see actually like how mineral water is conducting the electricity, right? And then there is a call R.D. Brown, which is in 1776. He also using the conductometry, obviously like the kind of process where you can experience the conductance properties. Or obviously like if you are trying to talk about the conductance in the solid, and the liquid actually how you are transferring the electron, which is going to convert in the form of energy, right? Then you see actually like this German scientist, which is Friedrich Kohlrausch. Again, the naming can be little bit difficult in terms of pronunciations. You can see that way. What he has done actually, he has investigated the conductive properties of the electrolyte, and contributed to the knowledge for their behavior, right? So that is in terms of like subject way you can try to see like how he might have done in terms of like how the electrolyte behavior is happening. Obviously he has to see actually like as we are taking the example of the salt actually. So obviously like what kind of solution you are bringing, and that solution how it is going to separated. Again, as you have to think a little bit on the bigger side about the acid base kind of titration, so you can easily see like how the ions is going to form right there, and that's how it can go. And obviously like there was another guy called Willis Whitney. What he was trying to do like studying the interaction of sulfuric acid, chromium sulfate complexes. So since you have done actually so many other kind of experiment, and we are going towards like a second last kind of experiment, you can easily try to find out like how the sulfuric acid is going to behave. Like if you try to see the chemical reaction, it is going to produce like if you try to defragment the sulfuric acid, which is sulfuric acid is like HNO3, isn't it? Right?
So H2SO4.
Okay, so you
Yes,
guys
yes, sir. H2SO4.
right. So you are going to see like how you can generate the sulfate ions right there. And if you're trying to talk about the chromium sulfate, you are also trying to see like how you can generate the chromium and the sulfate ions right there. And obviously like these are the ions actually when they transfer the electrons. That's how you try to see the like conductive behavior actually about the electrolyte. So that is where it is coming there. And then obviously like there is so many other people, they also go there, they try to formulate an instrument. And in that process you can see like in 1883 there is a guy called Robert Behrend, and then he was titrating the chloride, bromide and silver nitrate, right? So if you try to see actually like this is going to be a backbone in terms of understanding actually like how people were trying to take this kind of smaller chemical compound, which was helping in terms of finding the solution of this conductivity, or the liquid way of transferring the electrons, so that you can try to see actually like how the whole material is going to behave that way, right? Then the obviously like what he was trying to see actually like in this whole process, like they were trying to see like how the hydrogen the ion concentration is going to come. And again if you try to see with this example of sulfuric acid or the chromium sulfate, right, you can see actually like what is going to generate actually in terms of like whether it is acid base or whether it is going to be redox type of titration. Again that goes like how the reaction is going to behave right there. Okay, so you have seen that in the previous set of experiment as well, like what was the best example we provided for the acid base titration. The NaCl was the best one. We try to give you the example when we were trying to discuss there. And then obviously like there is a variety of peoples actually which has worked in this area actually, so they try to bring it. So the research is still on. Obviously like the region concept has been established, but if you are willing to bring a more kind of solution, obviously like you can try to bring it, right? Then the another kind of concept what you should understand from this kind of slide as well, that you can see it is written one. I don't know what is written, what we should do with the one. Anybody has the idea? Yes or no?
No, sir.
So are
Okay.
these citations?
No. Then you
Like
have
at the towards the end, I can see Braun RD chemical analysis.
yes,
So
right.
that's taken from that part.
Right. Okay. Thank you. At least you applied your mind, and the same goes to 2 and 3. It is also written. So the why I want to give little bit emphasis on that, like want your attention right there, so that because you are the future scientist, so obviously like you need to look more kind of articles. Depends on your interest area, whether it is going towards electronics, physics, chemistry, or computer science. So that's how you can try to see. So when you can read like this, like either it is going to come here or it can go even there. Okay, so one is like a reference. Okay, the reference is like what if you have to talk about this kind of terminology, like using conductivity to determine water purity. So you are not sure actually how you can determine the water purity, right? So with that way, there is a guy called R.D. Braun. So what he has done, he has a published. So you can see it is written chemical analysis. So that is kind of encyclopedia of Britannia. So that has been published, and there is a reference already, like 2015. That is the year he has done, and the wave is 7 December 2015. So that is the way. If you have to read more about any articles, right there. So you have to follow the reference. So if it is one, most of the time, if you have to go, I don't know whether you have heard about ACS, RSC, Elsevier. Have you heard about this terminology? Not yet.
No,
Not
sir,
yet.
not really.
Okay, so these are like the publication companies. Like ACS is American Chemical Society, RSC is like Royal Society of Chemistry, Elsevier is like Elsevier is also a publisher which is having a good domain. Springer, you might have heard about Nature and Science kind of group. So Springer, like there is a Nature's group are there. Then there is like a Francis Taylor, CRC price. So there is a different kind of price is there. So what used to happen actually, they try to bring the scientific knowledge right there, and they try to publish. So here you can see like this is kind of encyclopedia. I think you can also look in future as well how you can try to do. And if you try to see the second and third reference, you can see it like it is going the names, because it's not done by one people. You can see from this one it is going a Robert Behrend, but here if you see it's not only one, there is two peoples. What he has done actually, history of electroanalytical methods, and the journal name is called Electroanalysis, and it has been published in 2010. And this is the volume, and this is the page number, right? So this is the way you try to see even with the other references. So when you try to bring it in your research, anything you are studying, even the books you are studying, novels you are studying, and if you try to see that reference, it's better to verify so that you can have a better understanding, right? Then why we are talking a lot actually on all this concept of like a reference or the history, or we talk about the Tesla cars, we talk about something. We are not doing like just we are talking, and we also talk about the Cape Town, and one of you has given a very nice idea about that is the only kind of a city who experienced that zero water. Okay, and I can tell you, my friend, that was really a nightmare in South Africa, especially in Cape Town, because they were not taking even bath for 7 days. Hotels were also like empty, and if they are going there, obviously you have to buy one bucket of water, and that will cost you a lot of money. And other kind of city, they used to donate like just for the drinking purposes, they are trying to donate like a glass, just like the bottled water or something. We have also done that way. So the whole idea is like how we can try to find the solution with that way. What are the processes you can involve, right? We are not going that direction, but we are trying to bring it like if you have to understand this conductive metry, where it is going to be more applied. So obviously the first thing is like water pollution. Okay, so that is the one way we try to give you the one example, because the Cape Town is completely surrounded by the two ocean, which is Atlantic and Indian Ocean, and there is a like a meeting point. You can also see that place is called Cape Logus. So if you visit sometimes, I think it's a wonderful city actually, and you can see that way. Obviously, like the color, you can easily see how the Indian Ocean is going to look like, or how the Atlantic Ocean is going to look like. But obviously all these things what we are bringing, that there is too much water there, so with that one, how we can sort out the problem of water, we can desalinate. That is the desalination process, and you can see there is a different kind of industries are there. And if you try to come up from that side to the Middle East, right, And Middle East, if you also come there, you can also face the similar kind of issues are there, because that is a desert area. So obviously with the water, like maybe if you are interested to have some other kind of beverages, it may be costly than water. So water is really very costly. And with this one, when they try to take the salt, actually they also try to bring the rain. I will leave it the concept on you actually to think like how they can create the rain when they are trying to take out the salt, and how they can try to bring it, because you guys are good engineers to think about it, right? So obviously, like the water pollution, because there is a bigger issues like nowadays when you walk around your nearby area, you can try to see actually like the rivers and lakes are like quite polluted. And in that pollution, actually like how you can try to bring certain kind of concept, we try to do like a nano composite or the membranes you might have heard. Obviously, like every time if you see in your houses as well, there is a small box where you try to take the water just to drink, and everybody say like please use it, isn't it? Do you know what is that is like a kind of machine in your house?
Water purifier.
Yeah, you call it water purifier, but if you have to go a little bit more on the chemistry side, that is like they try to see like if they are using the membranes, it called RO. I don't know. You might have heard actually the terminology
Yes, sir. RO
telling.
and UV.
Yes,
RO filter.
Right, right. So you try to see the RO. RO is nothing, it's called reverse osmosis, right? So reverse osmosis is a process. This is like they try to put a membrane. Obviously, there is a lot of loss of water there, because the filtration is quite like a slow process. It is consumption of the energy as well. So you can see like that is a kind. So obviously, like when you are looking for the water pollution, you can also think about that way, like yes, our water is not pure. That is why we are using the what you call water purifiers, RO, purifier, or there is several ways you try to bring it. Nowadays, they are also bringing like to clear the humidity as well. I like I don't know whether you heard that called humidifier. Have you heard that in the market?
Yes, sir. Heard
Yeah.
about it.
Right, right. So what they are, trying to bring it like whether you have done that kind of, experiment before. So I don't know whether you can think about actually like what it is getting generated there. Okay. So, everything is science. Once you enjoy, it is like a good science, right? So what they are generating actually, what it is making the whole thing, because you will feel more cooler there, more breathing very easy than when you are like sitting to other rooms. So one room you put the humidifier, the other one you are just sitting like that. You will feel like it is getting you more relaxed. Okay, so I will leave it with you if you want to know. I will also explain that to you towards the end or somewhere if you want to. Right. So the first application is the water pollution, and I put more emphasis on that because that is our, research area where we try to, see the community, how we can try to bring and provide the solution in terms of like purifying. And there is a very different way of, purifying the water. It's not like only you do the boiling. That was our first experiment what we have done there, right? Like if you try to remove the magnesium and the calcium, remember the hardness of water. So that we have done, but obviously like if there is a permanent hardness, how we are trying to bring it. Then also we studied about the scaling as well, because they are trying to form some complexes, and that is the bigger issues it is coming, right? And then if you see the alkalinity of fresh water, the salinity of seawater, I think we try to cover due to deuterium ion concentration in the water, food microbiology, you can see tracing antibiotics, estimate ash content in the sugar juice, purity of distilled and deionized water, solubility of sparingly soluble salt, determination of atmospheric sulfur dioxide, estimation of vanillin in vanilla flavor. So there is a variety of, there is a good application. Obviously, you can see how this experiment is quite important for you actually, right? So as you are quite cleverly said, what is the kind of the titration we are going to see in today's experiment is kind of acid-base titration, and there is also like what we have covered in that terms, like there is a precipitation, replacement, the redox, and the complexometric titration. So you can easily see in that way. There is kind of some advantage and the disadvantage as well. You can try to see how you are trying to make this the solution. The biggest advantage is like you're not looking for any indicator here, right? And also, like if there is a colored or the dilute solution or the turbid suspension, that can be used for the titration. But obviously, if there is a very dilute solution or highly colored, obviously you need to look at like how you can try to see like how you can do your this experiment right there. Okay. Then obviously, like the temperature, obviously the pressure also plays a very important role. So you can see like that you are trying to maintain the temperature throughout your titration, and also the end point, which is you are determined accurately, because remember when you are trying to do the other kind of experiment, you have been told that you like it should not touch the wall, you cannot range or something like that. So why they are putting all this emphasis? Because you are trying to being like little bit educated in that way, like how the one drop can be like make really a big difference in terms of getting the right result actually, right? So that is very important. And kind of like industry, if you try to look like if people are quite interested in the beverages, so they try to use a lot of these kind of techniques. And then if you have to see the refinery industry, the polyelectrolyte solution, if you have to estimate, or the biotechnology, that's how you go. The food industry is coming right there. Okay, and then the micro biosensor for the environmental monitoring. That is the biggest advantage for these this kind of titration. And once you have to come with the principle, you can already see it like V is equal to IR, where the V is the potential difference and the I is the current. And easily, like this is the concept, like I am not sure actually whether you don't have any idea, but obviously like how you are getting the conductance of the you can easily see actually it is coming to the electrical current through the electrolyte solution. So that is the basic way you can try to see. And that is why I was trying to give you the example about the rod, which is like a metallic type of conductor, where the particle is transferring the energy to other one, and that's how you are going to feel it right there. Okay. So this is very simple way to understand actually like how you can try to do. There is an instrument called conductometer. That's how you try to do, right? And then we have to that is the tough part you have to also do actually. I think I am not going to go more details on that. I think when Vikas sir will come, he will try to explain. Actually, he is very good actually on explaining about like how and what amount you are going to adding actually in terms of like achieving the good conductance, and how you are going to get the end point. Obviously, if you try to see this kind of graph where you plot against the conductance and the sodium hydroxide when you are adding there. So obviously like you can get the end point. So obviously like he will explain to you. But if you have any queries on that way, I can also provide some solutions right there. And the procedure, I think that's how, with the video, audio, whatever way actually he tried to bring the solution, so that you can try to understand this one is very nicely, right? So you can see actually like how you have to maintain, and what are the standard solution you are putting there, and whether a standard solution is also playing a bigger role on that. So this kind of queries you should be having in your mind while he is discussing, so you can also try to see, right? And then again, obviously like you may ask like why you are going to maintain the temperature 25 degrees centigrade, why not 50 degrees centigrade? So obviously we are there to see, because one big reason is actually like this is directly proportional. As you are increasing the temperature, obviously your conductance is also going to go. How it is going to go? Obviously that there going to be forming more electrolyte, obviously, and that's how actually it is going to increase. Yeah, I mean the conductivity, right? So you can see actually like how it is going to go, how you have to put all the the processes in terms of like when you have to use the HCl or the standard solution, and then when you are going to add the NaOH, and obviously then you have to plot a graph. That is the very, very important thing for you. I think we are almost like in the closing stage. So obviously we know if you like what is going that side. So graph is really a tough part. But like once you are more attentive, then you can get. So he will be providing some data. Obviously, when you are doing here, you can get your own data. But obviously, everything we are going to the Einstein way, where you say like imagination is more powerful than knowledge. So we are imagining actually like this is the way you are trying to do, and this is more hypothetical way when we are trying to get the information on like how this could have been done, right? So that is very, very important. And then you will go to the calculation, which is since beginning it is coming our formula is N1 V1 N2 V2. I no need to explain about that, if what is N1, what is V1, and what you are going to calculate. Obviously you are going to calculate the strength of hydrochloric acid, and that's how you are going to finish today, right? So that is the way I have to explain today. I don't know whether anybody has any queries on that before I can bring Vikas sir in. Okay, it looks like everybody is quite happy. Maybe you like the story of Cape Town, maybe the zero water, right? And obviously, like I try to deliberately share this idea so that you can also see actually like what kind of solution you can also provide right there. You are the future scientist. Okay. So with that note, let me bring Vikas sir in. Jai Jagannath sir, you can take over.
Thank you, sir. Thank you. Okay. Good morning, class.
Good
Good
morning,
morning,
sir.
sir.
Morning, sir.
Morning, sir.
मुझे सुना नहीं दिया. Good morning.
Good morning, sir.
Good
Good
morning.
morning,
Good
sir.
morning,
Good
sir.
morning, sir.
Good morning.
Good morning, sir. आवाज कम होते जा रहे हैं. Good morning, class.
Good
Good
morning, sir.
Good
morning,
morning,
sir.
sir.
Morning,
Good
sir.
morning, sir.
हाँ अभी सुना दिया. Yes. Okay. So सब active हो. Very nice. Thank you. So me your but old experiment. Yes or no? Because the same type of experiments we already finished in last year in 2021. pH metric titration. This one is also the same types of experiment.
Okay, because sir, just 1 second, I want to stop you.
Sir.
I was getting some messages like whether you have any queries. Can you bring it to me now? If you have any queries, any kind of matters, can you bring it to this class now? Okay, so okay, I'm just taking like there is no question. So when you are writing, just make sure actually like we should better discuss in this class. Okay. Rather than because if there is a personal question, I do respond with that way. But obviously, if there is like collective kind of response I have to give, I have to always entertain in the class. Okay, so maybe if you have left some experiment or how you have to do it, I think we are going to do the defaulter class as well. So since you don't have queries, so I'm not telling. I think me and Vikas both we have explained to all of you like how we can do it in the previous classes. Okay, thank you, and sorry Vikas to interrupt you. Okay, take care.
Thanks, sir. Okay, the same types of experiments today also we are going to do. That is our conductometric titration. So the brief idea about the conductometric titration, a theoretical part of today's experiment, is being very nicely explained by Professor Mishra sir. So I hope you people have understood very well, very nicely. So now let us see practically how can you do the experiment. So as you must have gone through the aim of the experiment, where it is clearly mentioned that you are going to find out the strength of one unknown acid, that is hydrochloric acid, by using a standard alkaline solution. That alkaline solution is your sodium hydroxide, in conductometrically. Why it is called conductometrically? Because someone has given the answer that this experiment is belongs to acid-base titration. All of you agree with me?
Yes, sir.
Nice. Acid-base titration. But Nakshatra, I have little confusion that acid-base titration has also two types.
Sir, acidometric titration.
Yes, exactly. I'm very happy. This one is a particularly acidometric titration because you have been asked to find out the strength of one unknown acid, which is hydrochloric acid, where strength of base or alkaline will be given to you, whose strength is known. That's why it is written standard. Standard means strength is known to you. So like pH titration, there also you have been asked find the strength of acid by using standard base. But the process was that in pH metric, you have calculated the strength of HCl by measuring the pH, not by changing the color by doing a simple titration. But using one instrument, you have calculated the strength of acid by using pH metrically or by the help of the pH meter instrument. Exactly in the same way, the same HCl strength we are going to find out, but using conductometrically. That means you have to measure the conductance. By measuring the conductance, we can also determine the strength of one unknown acid. So here also, without using any indicators, we are going to estimate its strength. So now let us see how without indicators we can calculate the strength of one acid. That is our experiment. So as you know, by conductometrically you are going to find out the strength. So you are measuring the conductance. The question is that which conductance you have to measure. Your analyte solution is conductance you have to measure. Your analyte solution is your hydrochloric acid. Titrant solution, that is sodium hydroxide, whose concentration will be given to you. So basically, you know, those solution strength is given to you, that's you have to take in the burette, and the analyte solution whose strength you have to find out, that's you have to find out, keep it out in a conical flask or beaker. So you have to keep it out HCl in a beaker, NOH you have to take in the burette. Then if you are NOH to HCl, definitely the reaction will be continue because that is acid-base titration. So while the reaction is going on, and as you are not using any indicators, for how do you know whether reaction is neutralized or not? So to know the neutralization point, you are going to measure the conductance. So conductance you have to measure by using one instrument, that is conductometer. So whose conductance you will measure? Now you have to measure the conductance of HCl. So the total conductance value is depends on your H plus and Cl minus ion. तो H plus and Cl minus ions conductance आपका measure करना है. तो आज initially the in HCl solutions H plus ion will be maximum, and you know it has high ionic conductivity of H plus ion. So the conductance will be the maximum in pure acidic medium. So in acidic medium, the conductance of HCl will be the maximum, and you have to know or you have to calculate at which particular point your conductance will be the minimum where there will be one neutralization point. So how conductance will be neutralized or HCl will be neutralized? If you add base, I mean sodium hydroxide. Sodium hydroxide means Na plus OH minus. And you know OH minus ion has also high ionic conductivity. So once if you add HCl to NOH, gradually the H plus ion will be consumed by OH minus ion and it will going towards neutralization point. At a certain points, you can see it will form H2O and NaCl. One ionized water will be formed which is your neutralization point. At that time, your conductance should be the minimum. Because as conductance depends on H plus and Cl minus ion, in initial stage, the conductance should be the maximum. Once if you add NOH by adding 1 ml, 1 ml, so some H plus ion will be consumed by OH minus. So whatever conductance was there, that will be decreased. Then you add another 1 ml, again some H plus ion will be consumed by OH minus, and again the conductance will decrease. So it will decrease until and unless all free H plus ion is not neutralized by OH minus. Once all H plus ion will completely react with OH minus ion and it will form H2O, and that will be our minimum conductance. But after getting minimum conductance, again if you continue by addition of NOH, then due to unavailability of free H plus ion, the conductance will start increasing due to OH minus ion. It will start increasing. So once your conductance value starts increasing, means you should know, so we are already beyond neutralization point. So before that, somewhere your neutralization points has already came out. That's you have to find out. You have to note down at which particular points we got the minimum conductance. Then again you continue by adding 1 ml, 1 ml, 1 ml, again the conductance will start increasing. So nature of the readings of conductance is like this. First it will decrease. Again at a certain points it will start increasing order. So decreasing and increasing, that is due to OH minus ion. So you have to find out on which particular points we got the minimum conductance. So by measuring the conductance value by using instrument, we may not get the exact end point, because you must have seen the observation table that each observations we are adding 1 ml of NOH. After adding 1 ml of sodium hydroxide, you have to measure the conductance by using instrument. So 1 ml means there are minimum 20 to 25 drops. But overall you are doing the volumetric analysis. So in your volumetric analysis, where endpoints depends on a single drop of your titrant value. Just एक drop में आप लोग endpoint आ सकता है. But we are not adding drop wise. We are doing a lot of 20-25 drops. So you may not get the exact endpoint from the observation table. So that exact endpoint you can calculate or you can determine from the graph. That's why this experiment also you have to plot a graph. From the graph, how you do the graph? Now by taking decreasing point, another increasing points. So there are two straight line you will get. By decreasing point, you have to draw a straight line. Again, by taking increasing point, you have to draw another straight line, where both the straight line is coinciding each other, or intersection points will be your minimum conductance, where your unionized water is being produced. That is neutralization point. And that neutralization point of NOH value you have to use in your calculation, which is law of equivalence N1 V1 N2 V2, because to know the normality. Because you know, to find out the strength of any unknown solutions, first of all you should know the normality of that unknown substances. Unknown substances here HCl, so whose normality first you should know, and to know that normality you have to follow law of equivalence N1 V1 N2 V2. So once you know the normality, then simply multiply the equivalent weight of HCl. So easily you can find out the strength of HCl without using any indicator. So this is very easy experiment. Once the instrument is okay, because you know, before starting the experiment or before measuring the conductance or before using, before taking any data for any experiments, first of all that instrument should be checked. That should be standardized. That should be standardized, or that should be calibrate. So that calibration or standardization should be done by using any selective solutions which should have some scientific value or standard value. You just recall when you did the experiment of pH meter, potentiometer, आप लोग उसी दोनों एक्सपेरिमेंट को स्टैंडर्डाइज किए थे कि नहीं, एक स्टैंडर्ड वैल्यू लेके क्लास
Yes,
कुछ
sir.
याद आ रहा है? तो
Yes, sir.
एग्जैक्ट उसी हिसाब से here before measuring the conductance, first of all we should confirm, we should ensure that those instrument is being given to you that is in proper working condition, which can measure the exact conductance value of our analyte solutions. So how do you confirm? Now you can confirm by using one standard value, standard solutions. So to calibrate the conductivity of solution instrument, your standard solution is your potassium chloride. All of you can note down it. That which solutions you are using to calibrate the conductometer instrument, not KCl, because that instrument is been calibrated using that solution only. Like pH, can you tell me what was the solutions?
Buffer solution.
Very nice. Before buffer was the standard solution for using for calibration of pH meter. Exactly these experiments for conductometer as instruments, you are using potassium chloride as a standard solution. As you are calling that standard, you are going to measure the conductance. So this KCl conductance value should be known. Then we can say that is standard. So in room temperature, the KCl standard value or conductance value is 1.41 millisiemens. 1.41 millisiemens is the standard value, is the scientific value of KCl solutions, like buffer solutions, pH 4.01 or 9.20, anyone you can use, because that too is the standard value of instruments or the pH meter. Exactly for conductometer, your standard value is 1.41 millisiemens, small m, capital S. Millisiemens is the unit of conductance. So different instrument has different standard value, which you have to remember, right? So by using KCl solution, first of all we have to calibrate the instruments. Then instrument, if it is showing the real data or 1.41, then we can say yes, instrument is okay. Then you can go for the measuring of your conductance of your analyte solutions. But once if your conduct instrument is not showing the real scientific value, I mean 1.41, then manually you have to adjust it. That's manually you have to set the instrument. So once the instrument is being set up, then you can go for the measurement of conductance. So in this way, we can carry out the experiments. We can do the experiments without using any instrument or by the help of the one conductometer instrument. Are you getting something, class?
Yes, sir.
Yes, sir.
तो अभी हम लोग देखेंगे प्रैक्टिकली कैसे करेंगे. थोड़ा टेक्निक को आप लोग देखोगे, फॉलो करना है तो आपको आराम से इंटरेस्ट आएगा. थोड़ा जस्ट 1 मिनट, इधर इको हो रहा है, मैं थोड़ा विंडो खोल देता हूँ. जस्ट 1 सेकंड. Hello.
Yes, sir.
Okay, nice. So let us start the practical part. So as usual, like every classes, so whatever data we will be writing on the board, that is not required for you, but you just try to understand. Let's see. अगर हाँ बीच में अगर आप लोगों को समझ में नहीं आएगा तो उसका इंस्ट्रूमेंट का ऑपरेशन कैसे मेजरमेंट करना है क्या नहीं, तो आप लोग थोड़ा कहीं पे कॉपी में लिख के रखो, क्योंकि बीच में भूल भी जा सकते हो. Once my explanation is over, then you can put your question, we can discuss. Clear?
Yes, sir.
Okay, nice. Let's see. So I hope you can see my screen.
Yes, sir.
Okay,
Yes,
nice.
sir.
Thank you.
Yes, sir.
So conductometric titration. So you see, is Mr. S.K. Das, Sushant Kumar Das, is one of our colleague. So let us see how the Sushant sir has did this experiment. Okay, let us see the common things. You know, before starting the experiment, first of all, it should be aware about the instruments or glasswares or chemicals. And you see, these are the chemicals which you need. One is sodium hydroxide, whose strength is known. This is the HCl, whose concentration you are going to measure. And this is the KCl solution, which is standard solutions, whose conductance I told you it is 1.41. And another two bottle is distilled water and KCl solutions. So these are the chemicals we need. Okay. Then this is our magnetic stirrer. And you can see one electrode is also there. So I'm not going through the electrodes because I hope you must have read the details about the electrode in your theory chapter that is in electrochemistry. So in electrochemistry, you must have read about the different types of electrode. Okay. Now directly let's start the experiments, because you know whenever you are doing any experiment, first of all it is first duty to wash all the glasswares in the distilled water and same respective solutions. So I think that part is known to you, so I can little forward the video directly. Already people know. And while you are taking a solution in the burette, first of all you should ensure that in the burette there is no air gap, and basically the air gap remains in this part. In this part, you have to very carefully observe it whether there is any air gap or not. If any air gap, first you have to remove it. Like in this way, you see, sir is going to remove the air gap from the burette. This is very important, right? The burette should be completely filled from top to bottom. I mean top to bottom to end point of your zero, up to zero, or from any whole number you can also start. Now we can say the burette is going to be ready with sodium hydroxide, whose concentration is known. I will give you while we will do the calculation. I will give you. Now adjust your initial value or any whole number you can start. 0, 1, 2, 3, from any whole number you can start, because you must have seen the observation table that each observations we are adding 1 ml, 1 ml. So it is not mandatory to take from 0. Anywhere you can start, any whole number, you see. But sir is starting from 0. As HCl is your colorless solution, so we should go for the lower viscous. Now you see, burette is ready. Now we have to pipette out our analyte solution, which is HCl, by using pipette. And you see, this is the pipette of 50 ml. 50 ml of pipette. So we need little more solutions for doing these experiments. We have to pipette out which solution? Now HCl, hydrochloric acid. Now you see, sir is pipetting hydrochloric acid using 50 ml of pipette. And these 50 ml solutions we have to transfer in a beaker, not in a conical flask, in a beaker, because you are going to immerse the electrode in that solution. So it need little wide space. So, but in conical flask, the mouth is very little skewed. That's why we are using a beaker, so that electrode can dip properly without any problem. Now you can see the burette is ready with standard sodium hydroxide. In the beaker, we have pipetted analyte solution, I mean HCl, and we are not going to use any indicators. So the solutions are ready. Now let us see directly to the instrument, that how we can measure the conductance using conductometer instrument. So as I told you before that, you have to be calculate or you have to standardize the instrument. Now let us see how we will standardize the instrument, how we will operate the instrument of conductometer. You can see. You see, so there are three knobs. See, there are three knobs. One is your temperature, second one is mode, and third one is your range. And the second in middle knob where it is mentioned mode, there are three options. One is your temperature, then conductance, then conductance at 25°. You are going to measure the conductance at room temperature. So instruments should be calibrated in room temperature. Room temperature basically starts from 25 to 30. So at any temperature you can measure. So first what we will do, now we have to change the mode at temperature. Temperature part में हमको लाना पड़ेगा. Then using this temperature knob, we have to set the temperature in this display. Once your required temperature is being set up, then you have to change this mode at 25° centigrade conductance. At whatever you set up the temperature, at the same temperature you should start. You should fix mode and temperature. This two knob should be fixed. Now you see. Then I will tell you about the range. You see, third one is here about range. Let me explain the range. अच्छा, ये दो पार्ट का समझ में आ गया ना, टेम्परेचर एंड मोड क्लास?
Yes, sir.
Yes, sir.
Okay. The range button कब choose कर? कैसे? When you select the range. Class, as you know, the pH range, pH value range is 0 to 14. So in 0 to 14 there are three divisions: less than 7, more than 7, or equal 7. Acidic, basic, or neutral. So the pH range of any solutions. Exactly today we are going to measure the conductance of HCl because we have been given HCl. So scientifically it is observed that the HCl, the conductance value, the range is lies in between 2 to 20 millisiemens, small and capital. This is the millisiemens, this is microsiemens. Millisiemens, right? So 2 to 20 millisiemens. The minimum range of conductance of HCl is 2 and the maximum range will be 20. The question, when you will choose 2 and when you will choose 20 range. Not to be confused, because you know 2 means if your solution's conductance value is maximum 2 or less than 2, you have to choose range 2. And if the conductance is more than 2, you have to choose range 20. Once again I repeat, for conductance of HCl, the maximum range is 20, the minimum range is 2. 2 to 20 in between range is there. So when your solution's conductance will be less than 2, you have to select the range at 2. If the conductance will be more than 2, you have to select range 20. Now questions maybe comes in your mind. अब तो पूछो नहीं, मैं पूछ दे रहा हूँ, सर हमको कैसे पता होगा? How do we know that solution's conductance is less than 2 or more than 2? आपको पता होगा क्या? May not be ना? Yes or no?
Yes, sir.
तो इसमें देखो टेक्निक क्या है? Just now I told you. Just now we are going to calibrate the instrument by using KCl solution. So what was the KCl's conductance?
1.4.
So 1.41.
1.41.
Yes, sir.
Achha, 1.41 is less than 2 or more than 2?
So less than 2.
Less
Less
than
than
2.
2.
Less than
So
2.
when you do the calibration part, you have to choose range 2, right? At 2, at the fixed temperature, in this display, once you dip the electrode to your KCl solutions, in this display there should be 1.41. Dekho, 1.41. How many decimals you are getting? 2 decimal value. Yes or no? 2 डेसिमल वैल्यू। तो इसमें आपको थोड़ा कुछ आइडिया मिल रहा है कि यस, इफ द कंडक्टेंस वैल्यू इट इज कमिंग लेस देन 2, so the conductance value should be 2 decimal. 1.41. So once calibration part is over, then you continue for adding calculating the conductance of your unit solutions. तो पहला ऑब्जर्वेशन आप लोग देखो क्या लिखा होगा, थोड़ा इसमें स्किप कर रहा हूँ, होल्ड करो, इस पार्ट में आऊंगा बाद में। अभी देखते हैं सर क्या करे, मैं थोड़ा एडवांस चला गया, सर पीछे रह गए। देखो देखो अभी सर क्या करने जा रहे हैं, मैं भी जो जो चीज बोलो उसको थोड़े से फॉलो करो। तो फर्स्ट सर क्या करेंगे ना, फर्स्ट सर हैज टू चेंज द मोड, यू सी नाउ इट इज अ टेम्परेचर, now using this temperature now we have to set it 25, already it is 25 degree है। अगर सपोज चेंज हो जाए तो using this knob you can adjust, right? This is the adjustment temperature knob, you can fix it 25. Suppose we are going to take the conductance, or we are going to measure the conductance at room temperature 25 degrees centigrade. So now we have to change this mode, conductance at 25 degree, conductance at 25 degree. Okay, now you see, so these two knobs should be fixed. Now you should not change it in between, we should not change. Now let's come to about range. As I told you, we are going to measure the, we are going to calibrate the instrument, so we have to fix the range at 2, because whatever solution is being given to you for calibration purpose, that is your KCl, and KCl conductance is less than 2, so we have to fix the range at 2. Now you see 2 millisiemen, तो रेंज 2 को रैप के हम लोग को देखना है। अच्छा क्लास समझ में आ रहा है ना कुछ कुछ?
Yes, sir.
ओके,
Yes, sir.
नाइस। देखो now we have to select the range at 2. Okay, range 2. Okay, now this is the KCl solutions at 0.1 normal, at 0.01 normal the KCl conductance value is 1.41. This value you have to remember, right? You have to remember. Now what we will do, now we have to dip the electrode to that solutions. Before that you have to wash it by using distilled water. So using distilled water you wash it, and you see conductance कितना दिखा रहा है, 0। क्यों 0 दिखाएगा distilled water में?
There are no minerals in it, no?
Yes, there is no ions, there is free of ions in the distilled water, that's why the conductance is showing 0. So you see इंस्ट्रूमेंट को हम लोग कैलिब्रेशन करने जा रहे हैं, पहले डिस्टिल वाटर में वॉश करोगे इलेक्ट्रोड को, देन उसी इलेक्ट्रोड को यू हैव टू डीप इन योर स्टैंडर्ड KCl सॉल्यूशन. सो KCl सॉल्यूशन गिवन इन दिस बॉटल, उसी प्लास्टिक बॉटल में अंदर जो KCl से वी हैव टू डीप दिस इलेक्ट्रोड, देन इन दैट डिस्प्ले देयर शुड बी 1.41. If it is showing 1.41, so you can say the instrument is okay. But if not showing 1.41, manually you have to set it or you have to adjust it. So now add the KCl solutions. That is our. So distilled wash किया तो फिर KCl में rinse कर लो. because उसी KCl को यूज करने जा रहे हैं तो हम लोग थोड़ा rinse भी कर सकते हैं. एक्चुअली ऑलरेडी 0 दिखा है मतलब और जरूरत नहीं था, फिर भी बाय चांस कोई अगर कुछ वाटर में कुछ आयंस रह जाता है तो उसमें KCl में रिंस कर दो, बस हो जाएगा. ना देखो अभी इसको डुबाओ, डिप द इलेक्ट्रोड टू योर स्टैंडर्ड KCl, इट शुड बी 1.41, 1.41, but how much it is showing? 1.40. So is it correct now? Can you say the instrument is okay? I think my students are not getting me. But actually this conductance value it should be 1.41. But what is showing? 1.39. तो some error is there or not?
Yes.
Yes, sir.
तो इसको बिना कैलकुलेशन करके इफ यू कंटिन्यू, इसमें वो जितना % एरर है उसी एरर के हिसाब से आपको सभी रीडिंग्स देते जाएगा। तो जिस पॉइंट आप लोग सोचे होंगे ना ये मेरा एंड पॉइंट, बट एक्चुअली दैट मे नॉट बी एग्जैक्ट एंड पॉइंट, जो पहले से आपको एरर रीडिंग्स मिलता रहा। दैट्स व्हाई टू नो द एग्जैक्ट एंड पॉइंट यू हैव टू कैलिब्रेट इट, तो इट शुड बी 1.41। तो बेसिकली हम लोग जब पीएच मीटर किए थे, याद करो हम लोग कैलिब्रेशन कैसे किए थे, सामने वाला नॉब दिया था CL बोल के नॉब था CL, बट इस कंडक्टोमीटर में CL नहीं लिखना होगा, सेल्फ कांस्टेंट नॉब। Using self constant knob which is given in the back side of the instrument by using one tester moving clockwise or anti-clockwise, you have to set it 1.41. So moving clockwise or anti-clockwise, sir is going to adjust it 1.41. 1.41. See, now you can see calibration part is over. Now instrument we can say it is good condition. Now it is in working condition. It is okay. It is certified. Now instrument is tested. 1.41 it is fixed. Right? Sometimes क्या होता है ना, बच्चों लोग थोड़ा कुछ घुमा देते हैं, इसलिए थोड़ा नहीं तो एक ही बार कैलकुलेशन करके रखना चाहिए था। Anyhow, हम लोग each time हम लोग कैलकुलेशन करके देते हैं बच्चों लोगों को, है ना? So this is 1.41. So now instrument is okay. Now what we will do? Only we have to wash the electrode one times by using the distilled water. Then we can continue to measure the conductance of our analyte solution. So once again I repeat for calibration purpose. First of all, you have been given one standard solution of KCl whose conductance is 1.41. Then wash the electrode. Before that, you have to set the temperature knob by using mode. Then using temperature, specific temperature knob, you have to set up the temperature. Then fix the temperature by using the mode options. Then you have to select the range, because KCl standard conductance is less than 2, so you have to select the range 2. Then if the instrument all the knob is being set up, dip the electrode and you see whether it is showing 1.41 or not. If not, by using self constant knob which is given in the back side, by using tester moving clockwise or anti-clockwise, you have to set up at 1.41. 1.41. Then you can say that instrument is calibrated. Students, all of you understood?
Yes, sir.
Class? Okay.
Yes, sir. Yes, sir.
Okay. Now देखो अभी सर क्या करने जा रहे हैं, इसी बीकर में ये जो हम लोग पिपेट किए थे 50 ml. Now to these solutions we have to dip the electrode and we have to measure the conductance. But you can see the observation table class, that first observation it is clearly mentioned 0.0 ml of NaOH. I mean without adding NaOH in pure acidic medium, you have to verify the conductance value. जैसे आप लोग pH मीटर किए थे, याद आ रहा है? पहला ऑब्जर्वेशन जब किए थे बिना NaOH ऐड करके पहला pH मेजर कर रहे थे. Exactly.
Yes, sir.
Here also the first observations without adding any base, let us see how much its conductance value. As very beginningly, I already give you information that in pure acidic medium, the conductance will be the maximum, because the conductance is due to only free H plus ion and Cl minus ion. So in acidic medium, the two ions are sufficient, so conductance will be the maximum. But when sir has dipped the electrode to that HCl solutions, what is the reading showing in the display? How much it is showing?
1.
Can anyone
1.0.
give me some idea why it is showing 1 dot or 1 point? थोड़ा सोचो क्यों दिखा रहे 1 dot और 1 point? कुछ कोरिलेट कर पा रहे हो जो स्टैंडर्डाइजेशन के प्रोसेस, ये वाला प्रोसेस जो अभी करने जा रहे हो? मैं आपको hints दे रहा हूं. Just now we have calibrated the instrument. Yes or no?
Yes sir, वो 2 decibel तक था इसलिए.
Exactly. Thank you. Because just now we have calibrated the instrument by fixing the range at 2. Why 2? Because the standard solution's conductance was less than 2. But in the first observations, where we are going to measure the conductance in pure acidic medium, and that acidic medium, you know, the conductance should be the maximum. But we have chosen the minimum range. अगर ये solution का conductance value अगर maximum 2 और less than 2 होता, तो इस range में इधर readings दिखाता. As the conductance is maximum, so it is not possible to show the range within this minimum range. So what we have to do? Now we have to change the range at 20. So indirectly you got some information that 1 dot means the conductance is higher readings. So we have to change the range at higher range, that is 20. Are you getting me, class?
Yes sir.
So sir has to change the range at 20. Let's see. जितना टाइम डूबा वो उतना ही रहेगा, बिकॉज वो तो रेंज 2 के है ना. अभी सॉल्यूशन तो हमारा मैक्सिमम कंडक्टेंस आना चाहिए, तो रेंज उसके बीच में नहीं आ पा रहा है, तो इंस्ट्रूमेंट्स इज अनएबल टू रीड द कंडक्टेंस वैल्यू. नाउ देखो 2 से 20 कर दिए सर, तो कितना दिख रहा है? 3 point something दिख रहा है. तो फॉर ईच ऑब्जर्वेशंस यू हैव टू वेट फॉर सम टाइम्स सो दैट रीडिंग शुड बी स्टेबलाइज. देखो उसको डुबाओ, कितना दिखा रहा है देखो. दिस इज द फर्स्ट ऑब्जर्वेशंस विदाउट एडिंग एनी बेस, एंड यू सी दिस इज 3.9. 3.9 is the first conductance value of HCl in pure acidic medium. So first observation we can write without, I mean 0.0, that is 3.9. Then how much we have to add NOH? 1 ml. 1 ml NOH if you add, then some H plus ion and OH minus ion will react. So H plus ion will decrease, then conductance will decrease. Yes or no, class?
Yes sir.
Yes, sir.
उसी हिसाब से फिर उसमें फ्री H plus ion रहेगा, फिर ऐड करो 1 ml, फिर some H plus ion will react with OH minus ion. इस तरफ धीरे धीरे क्या होगा ना, all H plus ion will be completely neutralized by OH minus ion. Then it will form H2O. तो उसमें क्या होगा? सबसे मिनिमम कंडक्टेंस, बिकॉज मैक्सिमम कंडक्टेंस धीरे धीरे करते मिनिमम आएगा. जब पूरा ऑल H plus ion completely न्यूट्रलाइजेशन हो जाएगा, then it will start increasing. तो उसमें हमको पता चल जाएगा इसके पहले हमारा एंड आ चुका है. ना उससे सारे जाड़े 1 ml. तो you know, after adding 1 ml of analyte titrant solutions to analyte, you have to mix the solutions. So how to mix the solutions? Now using one magnetic stirrer. So to the solutions you have to add magnetic bead or magnetic pellet. Then moving this knob, you have to mix the solutions mechanically or automatically. You have to mix it. 5 to 10 seconds आप लोग मिक्स करना है. देखो ऑटो मिक्सिंग इज देयर. मिक्सिंग करने के बाद वही सॉल्यूशन में हम लोग को ऐड करना है, क्या डुबाना है इलेक्ट्रोड. बस देखो पहला वाला में था 3.9. नाउ फर्स्ट 1 ml, लेट्स सी. You see that the readings is coming decreasing. So that means some OH minus ion has reacted with H plus. That's why the conductance reduced. So it is 3.5. That means the reaction is going on. H plus and OH minus ion, the reaction is going on. So at 1 ml we got 3.5. That means still that's in that beaker there also free H plus ion is there. So till now the solution is acidic medium. Once conductance starts increasing, then you can say the solution is in basic medium. Now again add another 1 ml. So each time we have to add 1 ml, and we have to mix it, dip the electrode, measure the conductance. The common process. See, Class, are you getting me what I am explaining here?
Yes, sir.
Yes,
Okay.
sir.
5 to 10 सेकंड मिक्स करोगे करने के बाद बस सीधा उसको डुबाओ. Here also you wait for 10 to 15 seconds to stabilize the readings. So past 3.9 था, then 3.5, अभी देखो 3.1. So the reaction is going on and the conductance it is going to decrease. Again you got 3.1, but still the conductance solution is in acidic medium because अभी भी देखो less than अभी भी decrease हो रहा है. So now I can continue. I can little forward the video. You see how much it is showing 2.1. So it is more than 2. But आपको याद रखना है रेंज अभी कौन सा चल रहा है 20. Why 20? Because till now the conductance is more than 2. See 2.1. Next add another 1 ml. इस ऑब्जर्वेशन थोड़ा ध्यान में देखो कितना होगा. Another 1 ml sir is going to add. Mix it. See. Okay, now see the display. How much it is showing? How much?
1.9.
1.9.
1.9.
Now should you continue at the same range?
No, sir. Change.
कितना करेंगे अभी?
2.
2.
2 exactly. Because now the readings came less than 2, so we have to change the range. तो इसको याद रखो रेंज कब चेंज करना है. पहले 2 पे था नहीं आया हम लोग 20 कर दिए कंटिन्यू किए 4-5-6 ऑब्जर्वेशंस till less than 2. When the reading display showing less than 2, we have to change the range 2. When you change the range 20 से 2, definitely you will get 2 decimal value. Because I told you if the less than 2 it should be less 2 decimal value. But more than 2 था तो 1 decimal value आपको मिल रहा था. तो जितना ज्यादा डेसिमल होगा उतना मोर एक्यूरेसी होगा. देखो अभी दिख रहा है 1.8. So मुझे बताओगे 1.8 is correct और आफ्टर चेंजिंग द चेंज रेंज जो रेंज को चेंज करने के बाद जो रीडिंग्स आएगा वो करेक्ट होगा.
रेंज
रेंज को चेंज करने के बाद जो आएगा वो करेक्ट
होगा. उसमें 2 डेसिमल वैल्यू आएगा. देखो 20 से 2 कर दिए सर ने. देखो इससे पहले 1.8 दिखाया था. अभी देखते हैं सर को क्या दिखाएगा. पहले डुबाओ सॉल्यूशन में डुबाना दो पहले सर को. Now you see it was 1.8. now it is showing 1.84. I think 1.84 is more correct than 1.8. yes or no?
Yes, sir.
तो अभी रेंज कितने में है 2. 8.2 में कंटिन्यू करो. अभी भी देखो रीडिंग इज कमिंग डिक्रीजिंग. देखो अभी भी रीडिंग डिक्रीज हो रहा है इंक्रीजिंग नहीं हुआ है अब तक. मतलब अभी भी हमारा बिकर में जो सॉल्यूशन है दैट इज इन एसिडिक नेचर टिल नाउ. Now I can little forward it, continue. Now let's see. So now at range 2 we should continue until or unless again in the display it is not showing 1 dot. है कि नहीं? फिर रेंज 220 कब करना है जब देखो रीडिंग्स बढ़ते बढ़ते अभी डिक्रीज हो रहा है पीछे बढ़ेगा बढ़ते 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 और जब मोर देन 2 होगा तब क्या दिखाएगा डिस्प्ले में
1 point.
1
point.
हाँ. तो फिर जब तुमको 1 पॉइंट दिखाएगा आप लोग तुरंत क्या कर दोगे 20 कर दोगे. तो ये दीज आर द टेक्निक यू हैव टू रिमेंबर. कब 2 करना है कब 20 करना है. डिफरेंट केमिकल्स का डिफरेंट रेंज होगा तो इसको याद रखना है. देखो अभी लेकिन राइट नाउ आवर रेंज इज गोइंग ऑन एट 2. See what sir is writing there. The The same common process, only you have to add 1 ml, mix the solutions by using magnetic stirrer, dip the electrode, take the readings. Now see 1.10. Now you see, देखो तो रीडिंग्स थोड़ा इसमें चेक कर लो कैसा रीडिंग्स आ रहा था 1.10. See, I think now the readings conductance starts increasing.
Yes, sir.
अभी ये आएगा हमारा 10th, 10 में दिखा 1.10, 9 में 1.06, तो तुम्हारा एंड पॉइंट इसके बीच में है कि नहीं?
Yes, sir.
तो एंड पॉइंट क्या होगा?
So from 1.07 to 1.10.
7.2 तो नहीं. From the observation table, can you guess where should be your end point?
1.06 to 1.09.
Yes, ना 09 कहाँ? 09 कहाँ है? 1.10 ना? ये वैल्यू 1.10 है. मेरा स्क्रीन ठीक से दिखाई दे रहा था आप लोगों को?
Yes, sir.
Yes, sir.
देखो पहला मैं क्या बोल दिया था कि कंडक्टेंस डिक्रीज होते होते जाएगा once all free H+ ion is completely neutralized by OH- ion. At that time it will form ionized water, which is the minimum conductance point. Then due to unavailability of free H+ ions, then conductance will start increase due to OH- ion. तो हमारे इसमें इंक्रीजिंग होना शुरू कर दिया at 10 में. तो मिनिमम कंडक्टेंस जहां पे होगा वो हमारा एंड पॉइंट होना चाहिए, मिनिमम कंडक्टेंस वैल्यू. तो फ्रॉम द रीडिंग्स यू कैन सी द मिनिमम कंडक्टेंस इज 1.06, but 1.06 you got after 1.28. So 1.28 to 1.06, the volume of NOH we have added 1 ml. So on which particular point, which particular drops रिएक्शन कब खत्म होगा वो तो हमको पता नहीं चला. हमको कुछ मालूम पड़ा कि अब कौन सा ड्रॉप में रिएक्शन एग्जैक्ट खत्म हुआ है? नहीं ना. समझ में आ रहा है ना क्लास?
Yes, sir.
तो इसीलिए इस एक्सपेरिमेंट में जो एंड पॉइंट होगा ये तीनों के बीच में कहीं पे हो सकता है. ये तीनों के बीच में मैक्सिमम, आई मीन 8, 9, 10, 8, 9, 10 के बीच में कहीं पर एग्जैक्ट एंड पॉइंट तुम्हारा आएगा. वो आपको ग्राफ से निकलना है. Because we are adding a lot solutions, 20 to 25 drops. हमारा एंड पॉइंट जस्ट सिंगल ड्रॉप के ऊपर डिपेंड करता है. तो कौन सा ड्रॉप में वो हमको पता नहीं चला. That's why this observation table you are getting some rough idea that in between which point you are going to get the exact neutralization point. So we got some informations that in between these three we can get the end point from the graph. Now you continue by adding 1 ml, 1 ml, 1 ml. Now the conductance will start increasing. So I can forward the video. You see, same process, only you have to add 1 ml, 1 ml. So why you will waste the time? See, the same process you can see the readings. How up to 24 observations are as taken. You see readings are coming decreasing, then at a certain point it starts increasing. Starts increasing, यहीं तक आ गया. Then उसके बाद starts increasing. Then ये जो end point आपको यहीं से आपको यही वाला लेके आपको ग्राफ बनाना है, and from the graph you can able to find the neutralization point. Are you getting me, class?
Yes, sir.
So this is the common observation table. Now you can ask any doubt in observation table और कैलिब्रेशन कैसे करना है. आप लोग पूछना है तो पूछो, नहीं तो मैं आपको ऑब्जर्वेशन टेबल जो रियल डाटा आपको शेयर करूं जिसको लेके आप ग्राफ बनाओगे. ग्राफ में थोड़ा आपको हिंट्स दे दूंगा, उसी हिसाब से कैलकुलेशन करना है. समझ में आ रहा है क्लास? हाँ, आपको ये बोल सकता हूं कि देखो इसमें SAR has taken 24 ml, I mean up to 25 observations. So in your graph there may not be 25 units, and ये जो ग्राफ बनोगे इसमें you have to do the graph in landscape. वर्टिकली करने से नहीं होगा, लैंडस्केप में ग्राफ बनाना है. So let's see, we will discuss. Now should I close this page, class?
Yes, sir.
Okay.
Yes, sir.
Now let's see the data, right? I hope the screen is visible, right? So group 1 students, please note down the data. लिखते जाओ, just 1 second में आ रहा हूँ, लिखते जाओ. Okay, group 1 finished. Hello.
Yes, sir.
Group
Yes,
2.
sir.
ग्रुप 2 देखो, तो दोनों में शायद मैं 2020 ऑब्जर्वेशन दिया हूँ. And these data only you have to write down in your copy, and you have to draw the graph by taking this data. So I hope you have written the data. Clear, class? Both the group check कर लो.
Yes, sir.
Okay. अभी ये डाटा को याद रखो. Let's see the graph. ग्राफ को कैसे करना आपको? ग्राफ मुझे करना पड़ेगा या आप लोग कर सकते हो?
So you were saying about landscape, if you could
Scale
just
बता दो sir.
help us in that.
स्केल बोल दो हो जाएगा तो?
So in the landscape, yes, what you were telling us.
देखो, ग्राफ को थोड़ा उल्टा कर दोगे, मतलब देखो, आप लोग कैसे करते थे? ऐसे एक ग्राफ पेपर ऐसा है ना, आप लोग इसको एक्स, ये वाई लेते थे, ये एक्स लेते थे, है कि नहीं?
Yes, sir.
अब उल्टा कर दोगे, ये वाला को ऊपर जो लोगे, ग्राफ को थोड़ा घुमा दोगे. कैसे? देखो मैं दिखा रहा हूं. ये दिखा दे रहा है, देखो तो.
Yes, it's visible.
हाँ, ये सीधा
Yes,
है
sir.
ग्राफ. ये आपको एक्स होता है, ये बड़ा वाला साइड को वाई लेते थे आप लोग.
Yes, sir.
तो अभी ग्राफ को ऐसे उल्टा घुमा दो, जिसको वाई लेते उसको एक्स ले जाओगे, एक्स, और इसको ले जाओगे वाई. हो गया ना लैंडस्केप में? इसको बोलते लैंडस्केप ग्राफ. और जब भी जेरस करते हो, तो जेरस को लैंडस्केप में कैसे करते हो? समझ में आया ना क्लास?
Yes, sir. Yes, sir.
ये तुम्हारा देखो, ये एक्स एक्स, ये वर्टिकल है, ग्राफ स्पीड पर हमारा नंबर ऑफ ऑब्जर्वेशन ज्यादा है ना, तो आपको थोड़ा ग्राफ को ऐसा फुला दोगे तो ये आ जाएगा एक्स एक्सिस बड़ा साइड को और छोटा साइड का आ जाएगा वाई एक्सिस। ठीक है, तो उसी हिसाब से सपोज ये हमारा x and this is our y, this is 0। इसमें क्या लिखना है, यहां पर लिखोगे डिटेल्स वॉल्यूम ऑफ NaOH, लिखोगे एडेड, राइट। मैं तो क्रॉसर में इतना लिख नहीं सकता हूं, आप लोग लिखोगे। ये हमारा क्या लिखोगे, कंडक्टेंस CONDANCE, कंडक्टेंस। ठीक है, समझ में आ रहा है क्लास?
यस सर।
देखो एक्स एक्सिस में एक्स एक्सिस हम लोग क्या लिए थे, वॉल्यूम ऑफ NaOH, ईच यूनिट को 1 1 ले जाओ तो इजी हो जाएगा। हम लोग 1 1 लेके ही किए थे, ग्राफ डाटा लिए थे। सब में 1 1 को डिवाइड कर दो, 1 यूनिट, इस सब सपोज इस तरफ 1 यूनिट का आपको दिखा है सब में। देखो मैं क्रसर कर रहा हूं, मैं आप लोग समझने के लिए कोशिश करो, टीच होगा। सो दिस इज माय 1 2 3 4 5 6 7 एंड सो ऑन। वाई एक्सिस क्या करोगे ना, ईच यूनिट को इसे मार्क कर लो पहले, ईच यूनिट को ले जाओ 2, ये होगा 0.4, 0. ये पॉइंट है, ठीक से नहीं दिखा रहा है शायद, 0.6, ये 0. कितना होगा ये 8, देन 1 पॉइंट कितना होगा 0 एंड सो ऑन। सपोज ये तुम्हारा आया कितना 3.8, उसके नीचे वाला आएगा कितना 3.6। क्लास समझ में आ रहा है कि नहीं? हेलो,
यस
हाँ
सर।
सर।
तो मतलब y एक्सिस 1 यूनिट यू आर टेकिंग 0.2 मिलीसाइमन। कंडक्टेंस यहाँ पे लिखो स्मॉल m, कंडक्टेंस a स्मॉल m कैपिटल S, मिलीसाइमन, राइट। वॉल्यूम इन ml, इसमें यूनिट सब लिखना पड़ता है ना तो गलत हो जाता है।
So on y-axis, the first value is 0.12.
ना ना ना, यही तो प्रॉब्लम हो जा रही है, तो क्रॉसर में कर रहा हूं ना, 0.2 है, 0. ये पॉइंट है, मतलब 0.2 डिफरेंस वाई एक्सिस में, नो ब्रेक, इसमें ब्रेक देने की जरूरत नहीं। समझ में आ रहा है कि नहीं? यहाँ पे यूनिट ए ब्रेक डॉट है ना, ये डॉट है, यहाँ पे भी डॉट है ना, पॉइंट सिंबल है ना। नाउ इट इज क्लियर?
यस सर।
अच्छा, मुझे एनी ग्रुप बोलो, 0 में कितना वैल्यू था तुम्हारा?
3.4।
3.3।
अच्छा ठीक है, मान लो 3.3 देखो, सपोज ये वैल्यू कितना था, सपोज ये हमारा 3.4, ये तो नीचे वाला पॉइंट कितना होगा 3.2, तो जिन लोग का 3.3 बीच वाला में होगा।
यस सर।
3.3। अच्छा अच्छा, मुझे और पहले बताओ, ये जो वाई एक्सिस में लिए है 1 यूनिट इज हाउ मेनी स्मॉल डिवीजन?
0.2।
1 स्मॉल डिवीजन।
अच्छा वो तो एक्स एक्सिस में सर।
वाई एक्सिस में 1 यूनिट जो लिए थे
0.2 लिया था ना सर।
हाँ, तो कितना स्मॉल डिवीजन है उसमें 10,
So 0.02, one small
10
division.
स्मॉल डिवीजन 0.2 होगा तो 0.2 होगा तो 1 स्मॉल डिवीजन कितना होगा
0.2 divided by 2.
0.02.
0.02.
Yes, sir.
2 small division
0.04.
0.04. Then 3 0.06 multiple of 2.
06.
मल्टीपल
So
ऑफ 2
we'll
आ
keep
रहा है
on.
ना?
Yes, sir. हाँ.
Yes, sir.
तो जैसा आप लोग का 3.3 देखो 2.2 के बाद कितना 5 स्मॉल डिवीजन ले लोगे बीच वाला में 5 स्मॉल डिवीजन मतलब 0.1 समझ में आ रहा है कि नहीं?
Yes, sir.
तो उसी हिसाब से सपोज यहीं पे एक पॉइंट्स आया है, यहीं पे एक पॉइंट्स आया है और जो लास्ट जो तुम्हारा जो देखो 2 डेसिमल वाला वैल्यू आ रहा है उस पे हम लोग 2-3 पॉइंट्स को चूज करें। कोई एक पॉइंट्स बोलो 2 डेसिमल वाला। सपोज ये पॉइंट्स इस तरफ आया है ना, देन स्टार्ट्स इंक्रीजिंग किया था, ऐसे इंक्रीजिंग रीडिंग में आया। एनी 2 डेसिमल वाला वैल्यू बोलो तो कैसे पुट करोगे क्लास में ग्राफ में। सपोज योर पॉइंट्स आर कमिंग लाइक दिस, बीच में इंक्रीजिंग हुआ कि नहीं?
Yes, sir.
अच्छा एनी रीडिंग्स बोलो 2 डेसिमल का हम डिस्कशन कर ले।
1.55, sir.
1.82.
1.36
36.
ये पे 1.36 कैसे करोगे? 1 पॉइंट देखो 1 पॉइंट के ऑलरेडी है, देखो ये तो 1.0 है कि नहीं?
Yes, sir.
1.36 उसके ऊपर वाला कितना आएगा? ये 1.2 आएगा।
So we can get it because our one small division is 0.02. So we
0.2 यस एग्जैक्टली। देखो उसके बाद कितना आएगा? ये 1 पॉइंट, ये वाला आएगा 1.4,
1.4.
हमारा
So
कितना 1.36।
So
अच्छा इस बीच में कहीं पे 1.3 होगा
and then 3 more further
देन
divisions.
3 मोर स्मॉल डिवीजन। समझ में आ रहा है ना क्लास?
Yes, sir.
तो उसी करस्पॉन्डेंस दे दोगे। तो आपको हमेशा याद करो क्लास, मेरा बोलने का मतलब ये जो यूनिट्स एक्चुअली ऐसा नहीं, कोई टीचर नहीं बोलते हैं, मैं आपको बोल दे रहा हूँ क्योंकि मेरा मेथड ये है कि मैं बच्चों को बोल देता हूँ ताकि आप उसको नेगेटिवली लोगे तो गलत है, जो साथ हमको दे देते हैं तो हम लोग क्या कर रहे हैं। नहीं, एक्चुअली ये यूनिट्स आपको चूज करना है, लेकिन मैं सोच रहा कि मैं अगर बच्चों को बोल दूं ताकि इसके बाद तुम जहीं पे भी कुछ भी ग्राफ करो क्लास, ऑलवेज यू ट्राई टू नो द लिस्ट काउंट ऑफ द ग्राफ का, जो लिस्ट काउंट कितना है तुम्हारा वैल्यू। एक स्मॉल डिवीजन का वैल्यू पहले पता कर लो। एक स्मॉल डिवीजन का वैल्यू पता करने से आपको जितना भी डेसिमल वाला ग्राफ दिया जाएगा आप आराम से कर सकते हो। हमेशा जो यूनिट चूज करोगे एक्स एक्सिस वाई एक्सिस, हमेशा इवन नंबर चूज करोगे। इवन नंबर यूनिट चूज करने से आपको इजी होता, आसान होता है ग्राफ बनाने के लिए। समझ में आ रहा है ना? हमेशा एक्स एंड वाई को है ना इवन नंबर पॉइंट चूज करने से आसान होता है, जो वेरिएबल जो है। तो एनी हाउ 1.36 इसी हिसाब से करोगे। एंड सपोज योर ग्राफ्स पॉइंट्स आर कमिंग लाइक दिस, देन क्या करो देखो, ऑल पॉइंट्स मे नॉट बी ऑन द स्ट्रेट लाइन बट इट शुड बी ए स्ट्रेट लाइन। लेकिन स्ट्रेट लाइन नहीं आएगा। क्यों नहीं आएगा? क्योंकि ईच एक्सपेरिमेंट में, ईच ऑब्जर्वेशन में वी आर नॉट वेटिंग द लास्ट स्टेबलाइजेशन पॉइंट तक, थोड़ा हम लोग वेट नहीं कर रहे, थोड़ा वेट टाइम लगता है, तो हम लोग इसको ज्यादा वेट नहीं कर रहे, तो थोड़ा प्लस माइनस इधर उधर आएगा। तो इसीलिए हम लोग बोल रहे कि बेस्ट फिटेड ग्राफ बनाना है, एवरेज ग्राफ बनाना है। कैसे बनाना है? बेस्ट फिटेड लाइन। सो आपको ये जो डिक्रीजिंग पॉइंट लेके ऐसा स्ट्रेट लाइन ड्रा करना है ताकि ऑल पॉइंट्स may be on the straight line. If not coming on the straight line, you draw the line in such a manner so that almost all the points will very nearer to the straight line. But anyhow line should be straight. तो इसको ऐसे सीधा डाल दो, जो साइड में आना दो, फिर इसको थोड़ा बढ़ाओ, ऐसा बढ़ा दो, थोड़ी टेढ़ा हो गया ठीक है, लेकिन स्ट्रेट होगा लाइन। समझ में आ रहा है कि नहीं?
यस सर।
लेकिन ये जो ग्राफ में जो ये जिस तरफ है ना, ये गलत है। मैं जिस तरह ड्रा किया हूं, क्यों गलत है? देखो ये लास्ट पॉइंट में क्रॉस हुआ है, तो मैं बोला ना क्रॉस इंटरसेक्शन पॉइंट जो होगा वो होगा हमारा एंड पॉइंट, है कि नहीं? लेकिन तो
Yes,
जो
sir.
इंटरसेक्शन पॉइंट लास्ट पॉइंट पे है तो ग्राफ करने को जरूरत ही नहीं है, ग्राफ करने को जरूरत ही नहीं है। तो ये पॉइंट को मैं थोड़ा चेंज कर देता हूँ, ये ऐसा नहीं आएगा। तो ऐसा नहीं कि तुम्हारा लास्ट पॉइंट कंपल्सरी आएगा स्ट्रेट लाइन को, वरना नहीं आ सकता है ना? सपोज ए पे एक्स पॉइंट से एंड आपका जो स्ट्रेट लाइन ड्रॉ किया सपोज ऐसे आया है, एंड ये जो स्ट्रेट लाइन ड्रॉ किए थे सपोज ये ऐसा है, यहीं पे टच किया ये वाला, राइट? अरे मैं क्रॉसर में सीधा ड्रॉ नहीं कर पा रहा हूं मैं भाई, प्लीज।
Yes, sir. Sir, means at the cross, sir, at the cross point there shouldn't be any observation.
यस यस
Okay, sir.
एग्जैक्टली राइट। मतलब जो इंटरसेक्शन पॉइंट जो आएगा दैट शुड नॉट बी योर एग्जिस्टिंग पॉइंट, बिकॉज एग्जिस्टिंग पॉइंट ऑलरेडी तुम्हारे ग्राफ में है कि नहीं?
Yes.
तो ये जो पॉइंट्स को हम लोग क्या इसमें से हम लोग थोड़ा एक डॉटेड लाइन ड्रॉ करेंगे, ये पे जो आएगा इसको तो ऐसे आर सिंबल देके इधर लिख दोगे V2, ये वाला हमको ग्राफ में पुट करना है, ये यहाँ पर एक बॉक्स में रख दोगे ताकि आसान होगा कैलकुलेशन आइडेंटिफाई करने के लिए। समझ में आ रहा है? देखो एक्स एक्सिस में क्या लिए थे, वॉल्यूम, ये दिस मच ऑफ वॉल्यूम आई मीन 6 पॉइंट समथिंग हो चाहिए एज पर दिस ग्राफ, तो 6 पॉइंट समथिंग वॉल्यूम इज रिक्वायर्ड टू कंप्लीट द रिएक्शन वेयर योर अनआयनाइज्ड वाटर हैज बीन प्रोड्यूस्ड। ये होगा ना एंड पॉइंट, न्यूट्रलिजेशन पॉइंट फ्रॉम द ग्राफ। एज पर योर रीडिंग्स आपको पता लग गया होगा कहां कौन सा तीनों बीच में आएगा, जो रीडिंग्स देखोगे लास्ट इंक्रीजिंग पॉइंट उसके पहले दो रीडिंग्स के बीच में आएगा। गेटिंग मी ना क्लास? देखो कंफ्यूजन होने से मुझे बता दो इसमें, नहीं तो गलत होने से प्रॉब्लम होगा ना। ग्राफ में कुछ डाउट है भाई?
No, sir.
Sir, can you please repeat the last part?
एक्स एक्सिस, वाई एक्सिस, सपोज मैं स्ट्रेट लाइन ड्रा कर रहा हूं, एक लाइन आया है और ऐसे एक लाइन है, एंड सपोज तुम्हारा पॉइंट सब ऐसा है, सपोज आप लोग का जो पॉइंट सपोज ड्रा करते करते ऐसा है, पॉइंट वगैरह सपोज ऐसा आया है। देखो मैं क्रॉसर कर रहा हूँ तो ठीक से नहीं हो पा रहा है, फिर जितना हो सके मैं उतना कोशिश कर रहा हूँ, और इतना कोई भी ग्राफ ड्रा करके नहीं देते। एनीहाउ ये तुम्हारा x, ये y, ये 0, सपोज पॉइंट से कम लाइक दिस, तो ड्रा स्ट्रेट लाइन ऐसे ड्रा किया, ये फ्री हैंड में नहीं होगा। एनीहाउ यू हैव टू ड्रॉ द लाइन यूजिंग अ स्केल, those points are not coming on a straight line, just leave it, right? But you draw the line in such a manner so that the points will be very near to the straight line. Up to clear class? How to join?
हाँ सर।
Yes, sir.
Then जहां पर इंटरसेक्शन पॉइंट्स है वहीं पे आप लोग डॉटेड लाइन ड्रॉ करोगे, ये वाला एक्सिस, इसमें थोड़ा एक आरो सिंबल देके मेंशन कर सकते हो ताकि इजी होगा। ये कंपलसरी नहीं है, ये होगा V2 वैल्यू, ये वैल्यू हमको कैलकुलेशन में पुट करना है। ये पे तो आप लिए तो वॉल्यूम ऑफ NaOH है ना, समझ में आ रहा है कि नहीं?
Yes, sir.
ये तो आप लोग लिए थे NaOH, है कि नहीं? ये तो कंडक्टेंस।
सर जैसे ग्राफ में 1.85 को करना है तो कैसे करेंगे?
बोलो 1.85। अच्छा वेरी नाइस। 1.8 तक आप लोग कहीं ग्राफ में मिल चुका होगा आप लोग का पहले से, ये जो दिया था 2.4, 0.6, 0.8, सपोज A1, 1.2, 1.4, 1.6, 1.8, देन 2, ये 2, ये हमारा 1.8, ये तो लेकिन हमारा 1.85 है, तो ये जो 1.8 और 2 के बीच में कितना स्मॉल डिवीजन होगा? 10। इसमें 10 स्मॉल डिवीजन होगा ना इस बीच में?
यस सर।
तो 1 स्मॉल डिवीजन कितना आया था हमारा हमारा जो वैल्यू था
0.02
0.02 हमारा 5 है तो कितना स्मॉल डिवीजन चाहिए 2.5
यस सर
समझ में आ रहा है ना
हाँ सर
1.8 के बाद आपको 1 स्मॉल डिवीजन 2 स्मॉल डिवीजन एंड 2 3 के बीच में दे दो
ओके सर
हो गया ना क्योंकि 1 स्मॉल डिवीजन 0.02 2 स्मॉल डिवीजन 0.04 3 स्मॉल डिवीजन 0.06 हमारा तो 5 है ना ये तो हम लोग 1.8 के बाद 2.5 स्मॉल डिवीजन के बीच में हम लोग उसको एनसर्कल कर सकते हैं हो गया समझ में आया क्लास
सर
हाँ बोलो
सर आपने इंटरसेक्शन पॉइंट के बारे में भी एक प्रिकॉशन लेने बोला था मतलब वो ग्राफ में नहीं होना चाहिए वो वाला एक बार खोल दीजिए
हाँ हाँ ये जो देखो पॉइंट्स जो मैंने ड्रॉ किया जो पहले वाला जो ग्राफ किया था आपको जो इस तरह पॉइंट्स ये जो सपोज यहीं पे पॉइंट्स ऑटोमेटिक आ रहे हैं ना वो नहीं आना चाहिए देखो ये दोनों बीच में आया कहीं पे मतलब ऐसा कंपलसरी नहीं है जी सपोज ये तुम्हारा मिनिमम कंडक्टेंस वैल्यू सपोज ये मैक्सिमम था एंड ये दोनों ज्वाइंट होगा ऐसा कुछ मीनिंग नहीं है it is not mandatory to join first point first maximum conductance points and minimum conductance points no it is not mandatory आपको एक बेस फिटेड लाइन ड्रा करना है बस
ठीक है सर
बेस फिटेड लाइन ड्रॉ करो जितना पॉइंट आ सकता हो आपको लेकिन जैसे बेस होना चाहिए वैसा ही करो बेस फिटेड आप लोग समझो नहीं तो आप लोग समझो एवरेज ग्राफ या समझो मीन ग्राफ जैसे ड्रा करना है ठीक है
हाँ सर ठीक है सर
वो लेके इसी हिसाब से आप लोग ग्राफ बनाओगे और ग्राफ में एनी डाउट मैं जैसे ग्राफ
एक्स एक्सिस में 1 बिग डिवीजन इक्वल टू 1.0 ना
एक्स एक्सिस
हाँ
एक्सक्यूज मी सर
बिग डिवीजन इज इक्वल टू 1 ml होगा
ये भी डाउट होगा तो मेरा बच्चे का ठीक है मैं देख लेता हूँ
सर ग्राफ में पॉइंट्स लिखना तो नहीं है ना
ना नहीं ना ना ऊपर नहीं लिखने इसमें पॉइंट देखने को गंदा दिखाया जाएगा
ठीक है सर
अरे इसमें आप लोग ऐसा मत लिखोगे देखो मैं हमेशा आपको इधर शॉर्टकट में लिखता हूँ आप लोग वैसा लिख के छोड़ देते हो आपको लिखना है एक्स एक्सिस इज इक्वल टू 1 cm और 1 यूनिट क्या लिख सकते हो इक्वल टू 1 ml ऑफ NaOH ठीक है y एक्सिस y axis 1 cm is equal to 0.2 यहाँ पर एक पॉइंट सिंबल है पॉइंट से जीरो हो जाता है 0.2 स्मॉल m कैपिटल S मिलीसाइमन हो गया ना अभी ठीक है
यस सर
और ग्राफ के नीचे यहीं पे तो कंपलसरी है ये तो फिर बोलना नहीं चाहता फिर भी बोल दो रोल नंबर नेम डेट ये कंपलसरी ठीक है और कुछ बोलना है तो ग्राफ में बोलो आई होप नो डाउट इतना बोलने के बाद अगर फिर बोलो तो
सर
नहीं होगा
सर बिकॉज सर पॉइंट सारे लाइन में नहीं आएंगे तो पॉइंट्स में सर सर्किल बनाना है
सभी पॉइंट्स को सर्कल बनाना है ऑल पॉइंट्स यू हैव टू एनसर्कल
okay sir
those points are not coming understand just leave it no problem but you draw the line such manner so that that point is also very near to the straight line ऐसा नहीं है ऐसा नहीं कि तुम ऐसा स्ट्रेट लाइन ड्रॉ करो यहीं पे एक पॉइंट है यहीं पे एक पॉइंट है और यहीं पे एक पॉइंट है और यहीं पे एक पॉइंट आ रहा है इस तरफ पॉइंट्स आ रहा है ये सपोज इस तरफ पॉइंट्स आ रहा है ऐसा तो पॉइंट नहीं ज्वाइन कर सकते हो ना समझ में आ रहा है ना ठीक है
yes sir
then calculation please anyone can you read out the calculation please help करो मुझे फर्स्ट लाइन जो लिखा है वो लिखने का जरूरत नहीं, आपको लिखना है वी नो द लॉ ऑफ इक्विवेलेंस दैट इज N1 V1 इज इक्वल टू N2 V2, है कि नहीं?
यस सर।
यस सर। सर मतलब ये वॉल्यूम ऑफ NOH रिक्वायर फॉर कंप्लीट न्यूट्रलाइजेशन ऑफ HCl ये नहीं लिखना?
ना लिखना है। N1 you have to find out, right?
यस सर।
V1 कितना है लिखा है?
50 ml।
50 ml।
सर अब पहले से लिख दिया है तो फिर अब क्या करें सर?
लिख दिया था,
कैलकुलेशन
अरे बाबू लिख दिया था, लिख दिया, कुछ प्रॉब्लम नहीं। N2 ग्रुप दोनों का अलग अलग दिया था ना, नहीं दिया? अच्छा नहीं दिया है। अभी लिखो ग्रुप 1 का लिखो 1.03 by 20 N एंड V2 क्या करना है? फ्रॉम ग्राफ।
सर ये ग्रुप 1 के लिए बताया ना?
हाँ ग्रुप 1 बताओ। और ग्रुप 2 का N2 कितना लिखो? ग्रुप 2 का N2 1.04 by 20 N, और बाकी तो सेम है। N1 you have to find out, V1 is 50 ml, N2 ग्रुप 1 के लिए 1.03 by 20 N, ग्रुप 2 के लिए 1.04 by 20 N, V2 फ्रॉम ग्राफ। ग्राफ में कहां पर? जहां पर जो इंटरसेक्शन पॉइंट्स आ रहा है आप लोग का, ये वाला ये V2, ये वाला पॉइंट्स
एंड पॉइंट सर।
एंड पॉइंट, दिस द एंड पॉइंट। समझ में आ रहा है क्लास?
हाँ सर।
यस सर।
और इससे ज्यादा प्लीज नहीं हेल्प नहीं कर सकता हूँ, इतना कोई नहीं
सर
बताया,
जो
मैंने डिटेल्स बोल दिया हूँ।
सर N/20 दिया था सर, उसका क्या करना है?
बोलो।
सर एक्सपेरिमेंट में N/20 दिया था तो उसका क्या करना?
नहीं वो तो मैं ना, वो तो स्टैंडर्ड है ना, वो हम लोग कॉमन दिया था, हम लोग जब देते बच्चों को चेंज करके देते।
तो सर जब कैलकुलेशन आएगा तो अपन स्टैंडर्ड की जगह वो लिख देते हैं ना, N/,
वो तो कॉमन
तो
है।
N/20 लिखना है सर?
जो मैं अभी दिया हूँ वही लिखना है।
अच्छा ओके।
जो आपको दिया गया है ना वो स्टैंडर्ड हो गया ना आपका।
ओके सर।
वही को उसी हिसाब से आपको कंक्लूजन लिखना है। तो आई होप कंक्लूजन में किसी का कोई डाउट नहीं है। तो सेम फॉर्मेट है ना, पास्ट पासिव वॉइस में लिखना है बस। ऑल पे क्लियर?
यस सर।
ओके नाउ आई कैन क्लियर दिस पेज। Now I hope you people just little bit understood. Then आप लोग खुद करो ग्राफ करके 11:15 के बीच में आपको अपलोड करना है। 11:15 में लिंक will be closed, then you cannot upload it, right? And once again I repeat, before final submit, click the final submit button. Verify your PDF that you are uploading right PDF, and those graph you are uploading, that graph is clearly visible, please. And the sequence is common, same things. Aim of the experiment, apparatus required, chemicals required, principle or theory, observation table, then graph, observation table, then graph, then calculation. Calculations you are doing after graph na, calculation then conclusion, then last end कंक्लूजन साइड में क्या लिखना है? फिर आपका रोल नंबर नेम लिखना है। ऑन द फर्स्ट पेज द राइट कॉर्नर यू हैव टू राइट, सॉरी हाँ, लेफ्ट कॉर्नर यू हैव टू राइट योर रोल नंबर एंड नेम, एंड ऑन द ग्राफ राइट कॉर्नर यू हैव टू राइट यूनिट्स, लेफ्ट कॉर्नर योर इंफॉर्मेशंस, योर नेम, रोल नंबर, डेट।
ओके सर।
ओके, आई थिंक दिस इज अबाउट टुडेस एक्सपेरिमेंट। 20 डिवीजन नहीं आ रहा है तुम्हारा? कितना इतना नानोग्राफ क्यों यूज कर रहे हो भाई? A4 साइज ग्राफ अगर यूज करोगे तो A4 अगर आप यूज कर रहे हो तो 100% से 24 to 25 यूनिट्स होगा। इतना छोटा वाला ग्राफ मत करो, जिस तरह यूनिट मैं दिया हूं उसी यूनिट के अलावा दूसरा यूनिट आप लोग नहीं कर सकते हो। मतलब वैसा नहीं जो गलत होगा, लेकिन जो इंफॉर्मेशन दिया जा रहा है उसी को आपको इम्प्लीमेंट करना है बस। एक्स एक्सिस 1 ml 1 यूनिट 1 ml, वाई एक्सिस 1 यूनिट 0.2, ताकि मैं भी ऑनलाइन चेक करता हूँ ना, मुझे थोड़ा टाइम लगता है ग्राफ चेक करने के लिए। आप लोग इधर उधर यूनिट लेके करोगे तो आई नीड मोर टाइम, सो आई कैन नॉट गिव दैट मच ऑफ टाइम। फिर भी मैं आपको यूनिट्स दे रहा हूँ, और यूनिट आपको नहीं दे, आपको खुद करना चाहिए था। इतना सारा चीज करने के बाद भी गलत कर रहे हो तो सो फाइनली आई कैन से सॉरी। Anyhow, okay. Now, can you tell me, are you interested to see previous experiment mark?
Yes, sir.
Yes, sir.
क्यों देखो, वो तो पुराना हो गया ना, 1 साल के बाद कॉपी देखोगे।
सब पुरानी यादें ताजा हो जाएगी।
अच्छा, बहुत अच्छा है, ताजा होना चाहिए सबको। सेम चीज